Hello, welcome to section 7, part E of SAS programming course. In this one, we are looking into examination of the distribution of a single categorical variable. So, these kinds of examinations, so basically frequency tables, can be done using proc-frec procedure in SAS. Frequency tables are a most common way to examine the distribution of a single categorical variable, and we can get information like frequencies and percentages of each category using these tables. And of course, in addition, different graphs like bar charts, for example, are a good alternative or addition for this case. So this one we can do using proc-frec. Here we define that the data is found from KIR library reference and the name of the SAS dataset is experiment. In the table statement, we can define what kind of tables we want to create. So we are asking to create a frequency table from the variable quality. And in this additional option plots, we are requesting to create also a frequency plot. And this is the result we get. So first of all, on top of the picture, we have a one-way frequency table showing us that the quality category 1 is having the highest frequency with more than 100, and it's about 60% of all the observations. And of course, here in this case, also the bar chart is very nice because it gives us the same picture in a graphical form. But let's next go into a little bit or one step more complicated situation. So we are examining the relationship between two or more categorical variables. First of all, we can do frequency tables by subgroups, so that's basically the same we did here, but we just define a grouping variable. So we are doing the grouping here in the proc-frec in the by statement, and for that reason we sort the data according to the same by variable. So we have a proc sort with by location statement. And in the proc-frec, we have the same key things here, that we are saying that we want the table for variable quality, and we want to do it by location. And so this is what we get. We get for each location the same frequency table we did in the previous example. But we could also do cross tabulation. So we put the two variables in the same table, and we can examine the distributions there. So in this case, we are interested in examining the relationship between fertilizer and quality, two categorical variables, and and for that reason we create the cross tabulation. And also we defined this chi-sq option here in order to produce a chi-square test, which can be used to test whether there is a relationship between these two categorical variables. And basically what we are interested in is whether the distribution of the quality variable depends on the fertilizer level, but the actual test is a general test of relationship between these two variables. Also, here in the proc-frec, or we can do this also in the proc-frec as the previous example, but now we are defining the tables statement a little different. Earlier we only had one variable there, but if we now put the star between two variables, then we get the cross tabulation. And with this no col and no row, we are requesting to exclude column and row percentages from the resulting output table. And this was the one to get the chi-square test. Also the same as with correlation coefficients, that when we are now examining dependencies between variables, we are assuming that the observations are independent that we are handling here. And this is the output we get. So if we look into this table, and like I said earlier, we are mostly interested in comparing the different fertilizers that we have here in terms of the quality distribution. So we see that for the first fertilizer, the most common quality is this first one with 47, and then only 8 and 1 and 0 for the higher qualities. In the second fertilizer, it's roughly the same, so that the first one is the most common, but we have a little bit more or larger proportions also in the other ones. And then in the third fertilizer, it's completely different, because here actually qualities 1 and 4 are almost as common, and then these are a little bit less common, but still quite many observations here as well. So we already see that it's looking like, it's quite clearly looking that the fertilizer 3 is showing much more of these higher qualities. And in that sense, it's no surprise that if we look at the chi-square test, it has a small p-value indicating that there is statistically significant relationship between quality and fertilizer, which we already saw. The values we have here in the cross tabulation, you see the explanations here. So the one above is the frequency, and the one on bottom is the percentage out of all observations. And you also see the number of missing values here on the bottom of the table. Then we might run into a case where first of all, we have an example where we do the same, but we do it in subgroups. So we divide it into smaller groups. And in that case, it might be that we need so-called exact tests as an alternative to the one we already used. So we are now doing this same thing, but separately for each location. We do it using the by statement, so hence the sorting here again. And now in the proc-frec, we are saying that we again want the fertilizer and quality cross tabulations, but we want by location. And now there's not so many, or not as many observations in each group as there was earlier, put those groups together. So for that reason, we asked to produce this exact version of the chi-square test. And that's meant exactly for this kind of situation where the assumptions of the chi-square tests are not met because of the too small sample size. So this is the alternative for that situation. And here are the assumptions. So the chi-square approximation can be considered good when at most 20% of the so-called expected frequencies are less than 5, and all expected frequencies are greater than 1. And if these conditions are not valid, then the exact tests can be used as an alternative. And these assumptions are quite easy in the sense that we actually get a warning here in the output. So this is the 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 cross tabulation and the tests for location one. And for location one, we get this warning that 58% of the cells have expected counts less than 5, and chi-square may not be a valid test. So we get a warning, and it's saying that this should not be necessarily trusted. But we get the exact versions here, and this is the exact p-value on the bottom row, so it's still 0.005. So that's still saying that the relationship between fertilizer and quality for location one is statistically significant. So we see the same kind of behavior here, that in fertilizers one and two, there's more in quality one, and in fertilizer three, it's more evenly between qualities one and four. And in location two, we get the same warning. So we use the exact version, but that's also significant here. And we see the same kind of pattern between fertilizer and quality. So we also find out that it's a significant relationship in location two as well.